So, sorry, I was just hitting record. Wanted to make sure I was going to capture everything we were going to do. So, for the benefit of the recording, where are we up to? Where are we up to? Let me just pull up my file explorer. I think I've still got my files here. So, last week we used working with working with data. We've used this. We've looked at input boxes. We've looked at bringing in a new file and what it actually does when it does it. We started to implement an if and a case statement. So looking at applying this case statement to be useful for what we wanted to do, to offer different types of routines. However, what we really need is what about when we hit patterns. Now, don't follow me in this. I'm just going to take you through this process. I'm going to show you how disappointing this whole thing is. So I'm now going to hit record. We're past the point now. We know about the routines, and we know that sorry, 1 second. Yes, don't worry, I will be doing. For anybody who doesn't know, I am looking to try and emigrate all of the videos from YouTube and put them into Teams. Teams Stream just seems a bit more accessible for a lot of people, and it will just save you having to dart all over the sodding place. So I'm not deleting any. I'm just trying to emigrate them across, and then I'll be just using Teams. But again, and it will slowly happen. Right. So we're past the point now of really wondering what happens when it makes a new part. So I'm just going to do it. So we'll go into a new part, and don't forget, I am recording at this point. Again, don't follow me on this because I am going to make some mistakes, particularly for these reasons. As ever, I'm not going to insult anybody's intelligence. We've gone through the routines and we've gone through shortcutting and how much we should not do it. So what I'll do is I'll put a circle here, and then I'm going to do a circle here. And then, just for argument's sake, let's do a pattern there. Now, this is a it's a good tool, but it's a pain in the arse to get working. And what I mean by that is, I'm probably going to do this now, and it runs fine. I hope that's not the case, just because this can give you such a false sense of security. It's crazy. So, I'm just going to go into my dummy. And as ever, I don't need these. They're just my SolidWorks build initiations. I'm just going to let them be controlled. So we've got this here. So we've got the edit circle repeat. Let's come back, bring that across. Oh, bring that across to my second screen, and then let's just run it and see what happens. Thank God. So, I went through a cycle process. I went through that process. So, if I now just come back in again, I'm going to close that. I want to step this through to show you guys. Right, as we know, comes in, sets the part, activates a new document. I've left the numbering there. I'd normally get rid of that. Onto the front plane, inserts a sketch, gets rid of any crap, inserts the circle. That was my guide circle, if you remember. Then clears the memory out from there, so we've now not got anything highlighted. We can just see our original sketch. Then puts our sketch into position, and you see here it's into the edit circle, which, in other words, is a pattern. They are very temperamental. Patterns never seem to work right. They never seem to be reliable. Work on different people's PCs. Work on some, fail on others. Basically, it's to do with the release version that you're using. It's to do with the level of version that you're using. Bloody frustrating, extremely annoying. Totally get that. But there is alternate ways. there is different ways of doing stuff. What we're going to do today is just jump up a little bit further. Now, I was thinking about what could sort this out quickly. Now, one thing that I quite liked last week is 2 seconds. 2 seconds. So, yeah, we're going to look at two in particular: for loops, while loops, and then I want to just start to introduce you guys to a technique called subroutines. We will be using functions as we're going through, but subroutines are basically extra bits of code that run at the side and act like a toolbox. But first things first, let me just call some of these notes back up. One thing I really liked that we did last week is we worked through what I like to keep calling the challenges. Now we did that, so I'm going to close that one off. It was. I'm not going to do that one. It's an inverse version of the exact one that we've already done. That you could do that. That would be a long way of doing it, because if you want to control specific positions of points, and also something like this, if you're going to increment sizing. Now, I was interested in who might have a go at this, just to see. So it wasn't a big kick in the face. It was just to see who may have a go at this, because it is, as for anybody who's had a go, you've probably found it is a little bit tricky. Now, the big one though, which I do quite like, is I'm not going to solve this because it's a case statement and I want to really focus more on the loops. But one thing that you may have, if for anybody who's taken a look at this, I'm just going to build myself up an example where I need to add a fillet. Sorry, my Alexa keeps sitting opposite to go, oh, I'm gonna say something. Right, so I'm just gonna click on record, go top, and I'm just gonna do one line here, and then another line here, and then another line here, and then okay. Right, so now what I'm gonna do is put on a fillet, and select there. And then OK, and stop. Fillets aren't straightforward neither, so sadly today is just a day of just bursting bubbles of damn it, that doesn't work neither. So look at this. See this process? Creates a line and it says fillet. At sketch point fillet 1. So if I just run that again, I suspect this might still run, but we'll have a look. Yeah, didn't run. So the reason it doesn't run is it's actually wanting to know where all these things will connect. So there's a few ways. If I first record myself clicking on fillet, if I click line and then OK, and then stop. For anybody who's from the early days of CAD, you will know that that was how you used to have to apply fillets. The most annoying thing is on these now, when you click on a point, it's considered shortcutting. So that's one of the reasons why it wouldn't appear. But if I come back to this, see here, right, with that one little step closer, we'll copy that out. And again, I just wanted to do this for those of you who have been having a go at this. Right, so technically now we should pick on line 1 and then create a fillet. So click OK. Let's try this again. Duplicates. Don't forget, if there's a duplicate, delete it out. Run it again. You kind of go, shit! Why's it not working? Okay, so come back, click back out, let me step you through. This is where stepping through will save your ass when it comes to setting up automatic code like this. So we're in that process. Back to a set point. Clear all selection. Select line 1. Select fillet. And you go, okay. Now, for those of you who are very sharp with all this, let's see if this works, because it is the second line in this assembly, in this sketch, sorry. Stop playing, sketch, clear selections, line 1, line 2, line 1, line 2, fillet. It is literally because, see this point here? When it records it after the execution of the fillet. So what it does is it records it as a fillet. It shouldn't record it as a fillet. It would be better if it recorded it as a line. So in other words, if I rename that to line 2, that would create the fillet. And it's little bits like that that makes the SolidWorks system really efficient, but really frustrating at the same time. So that is the only way that you'll create fillets in such a way. Apologies, let me just see if I can pause any type of updates that's going on. I wonder if it's that. I've got my Citrix turned on. Never trust Citrix with stuff like that. And yeah, let me just try that. That may or may not help. I hope so anyway. Okay. So when it comes back to the notes itself, when it comes back to the challenge on this one, it asks you for, in different conditions, with a different length, get a different radius onto it. That is how you apply the fillet. When it comes to the case statement, I'll give you the solution for this, but it is literally a case statement to control that. So it's just one thing to keep in mind there about how to do it. Now, again, I'm not going to that one. It's this one I'm interested in. So it's this one that I'm interested in. And this one might work out really well as far as really exploiting some of the ideas for today. What I want to do though first is I want to take you through an idea, simple idea of creating geometry in a loop. So I'm going to close that. I'm not going to do any more on that because I didn't want to get rid of that. Nope. Right. So what I'm going to do now is look at creating a loop. Now the way that these things work, it's best you see if I write these to show you. Now what I'm going to start with is simply creating 1, 2, 3, 4, 5 circles in a row. That's all I'm after doing. But what we'll do is examine the different ways of actually creating it. Then once we've got that geometry, we're one huge step forwards. So I'm going to record, go new, and then part. This is much easier if we do this slowly and surely. So anybody who's used to for loops, anybody who's used to while loops, please do fire away of doing different things. But for me, I'm just going to go steady away with this, and then we can pause for any burning questions as we're going through. So what I really want to do is work towards this boss diameter pitch. So first things first, I'm going to go, for this I'll go top plane. It doesn't matter which plane you go, as we all know, it's just how you want to see it. I'm just pretending this thing's laid on a desk in my mind anyway. So what I'll do first is go. And that's it. I was playing around with this earlier, as you can probably see from my ones that I put out. I was just playing around because I wanted to see which one would work better, and really play out between the two. So let's first close that. And let's bring it in here. So again, what we're working towards is this. So with this, I know that's not needed. This, again, to remind everyone, this is for SolidWorks and its simulation tools. I don't need them on. I'm just going to let SolidWorks deal with that. Look here, we have counter. Again, I understand why the counter's there, so I'm going to let SolidWorks remain in control of that counter. And again, when it comes here, I'm just dropping that out as well. Right, so what I'm going to do is remove the user's options at first. I want to get this thing so I can create these patterns. Now, the thing that's a challenge on here, and the thing that a pattern system won't do, is increment in this way. So this, arguably, this is why this is more superior than your standard pattern system. I'm going to make somebody's message me. I bet you're going to tell me that it can. I've never seen it do it. Let me have a look. Oh, no, never mind, it was something else. So we're going to come back and then let's take a look at this. Again, what I'm going to do is take my time with this because I don't want to rush when it comes to this. We're dealing with that pain in the arse circles. And if we're dealing with the pain in the arse that is circles, we want to make sure that we are consistent. So, let's just make sure it runs. Happy days. What I want to do is I'm going to say that dim. I'm going to say C as a double. This will be my circle center. So I could do CC, but I'll just do C. And I'll put a comment on a circle center. Then I'm going to go dim R as a double. This is obviously going to be circle rad. Right, so we must keep in mind the rules that we've already been operating to. Now, I'm a real stickler with stuff like this. I do prefer that we set up a way of capturing what these values are. So if I say C is equal to, now for this case, we're just going to put a fixed value in there. Now the center of the circle, what it refers to is the position of where the circle sits at one particular time. So for this case, we're starting in the middle, and then let's move along 5 times, and we'll give an incrementation of, I don't know, 50 millimeters, just to give them so that they're equally spread apart. So I'll go is equal to 0. Now this is purely because circle starts at datum. And you've got to remember, because I've got that there, I could easily change that to an input box. And that's what I mean. I like to have stuff in there so it's all set up and I can just configure little bits when I want to. So I've got R is equal to, it's a rad, so I'm just gonna, I'll go 5. We can change that. I mean, I'm making too much of it, I think. So we'll go circle rad, and as ever, area. Units. C is equal to C over 1,000. R is equal to R over 1,000. So now we're starting to get everything where it should be. Now, I'm not going to do anything just yet. I just want to be sure this is going to work. So again, I make my small progress, my small steps. Again, I've had students before who could write these without even looking, and that is a special type of nerd. I won't lie. It's it's a phenomenal skill set. I shouldn't take the mic, but it is a phenomenal skill set to be able to do something like that. Right, so let's run it through. Make sure it runs. Get in here, and I'm gonna do my 10mm. Yep, so it was on the rad. It's exactly how we wanted it to be. Come back in again, right, and just to reiterate everyone that when I record these, I record to my hard drive, just because I don't trust the Wi-Fi signals. So I'm not actually recording from the Wi-Fi signal. So when you watch this back, you won't see any fluctuation, and that's one of the main reasons that I do it, to stop for a little bit of frustration when it can happen, because these things can go wrong. Right, so we know it runs. Now there's a couple of ways of being able to do this, and there's a couple of very sneaky ways. One is called the for loop, and what you do is you say for take something and then increment it between these two values. Increment it between these two values. So what we're going to do is do the same. Now I'm going to go small steps with this, because I appreciate it's a big one to take in. So I'm going to make some space. Here we know that the sketch gets inserted. So that's never going to change. It's always going to be the same. What I'm going to do is I'm going to declare. So I'm going to go dim I as an integer. This is now going to become a counter. So I don't have to declare units or anything. Now what it'll do is it's going to allow me to increment particular times. Now we've already set the circle center. Set the circle center. We've already set the circle center. So what we're going to do is we're going to set I, and we're going to say that I is between two particular values. So I'm going to say for, as in for, I is equal to 1, 2, 5. I'll show you where my 5's coming from. It's just in case anybody was unsure. Oh, wrong button. Apologies. My 5 is obviously coming from here. That's all it is. So what we want to do first is just get 5 circles to sit in a line through one command, this one. So this is what you would class as being intelligent programming. The trouble is in coding, intelligent is a very, very strong word, and used way over the top. Right, so what this will do is it will run in and say, right, I is equal to 1, and then run through a loop. Now when it comes, it'll come here, say I is equal to 1, go to the next one, run this, go to the next one, and run this circle. In fact, I'm thinking even that doesn't need to be in there, because don't forget that's already been declared once, so that can actually be declared there. And oh my god, we're actually down to 1 line of code. That's just naughty. So now what I want to do is, once I run through there, I want to move C along. Now I don't have any fixed values at the moment, but we said we'd go 50mm. So what I'm going to do is set another value here, and I'm going to call it D. This is just going to be the distance across. Position. 3. So now what we get is we've got a way to move it, which is the most important thing. So what I'm going to say is C is equal to C plus D. Now at this point D's not been set, but D doesn't need to be a particular well, it does need to be a particular unit actually. So we'll make D equal to 50 millimeters. And as ever, let's just make sure it's in the correct unit. And then here, what we'll do is go next I. So what it'll do is it will come in, run to 1, come along, and then increment itself by 1 to I is equal to 2, I is equal to 3, I is equal to 4, I is equal to 5. And it will repeat this process again and again and again. But what we've done is we've moved this across. But the thing is it going to work? So let's take a look. I'll pause it there because it's going to be nice to just see this step through. So if I run that, circles in, happy days. C is equal to C plus D, so C at this point becomes 50 millimeters. Next I. Brilliant. So this is where I get to pose questions back just to see who's actually been keeping an eye. What did I do wrong? There's no daft questions, by the way, because it's coding. You can do some really daft stuff in coding anyway. So there's no real daft questions here, but if we take a look back, let's just zoom it out. What's it doing? What's the first thing you can see it's doing? Apart from looking like a mussel from the beach. The one thing that you can see it's doing is, see that center of the circle? It is incrementing exactly like we wanted it to. Definitely moving like we wanted it to. But it's all coming from the exact radii. It's all coming from the exact same position. So, with that then, if I come back, this is, by the way, one of the main reasons that we've been looking at positioning, why we've been looking at circles, just because getting these running and getting these to increment themselves in such a way is a bit of a pain in the backside, but it's worth it. So, what if we say R is equal to R plus C? Would that help? So we've taken the center of the circle, which has now been a new value of D, and we're just incrementing it along to actually move it, to help it along, so to speak. Let's run that in. So we run in, step to the next. So we've now made it. Yeah, that's good that. So now we're in a position of is where it will jump out. Now our 2 increments here worked. It gave us that position, but something went wrong onto the next iteration. So it gave us that position, but something went wrong on that next iteration. So we've got there to there. So what we're going to do is come back and just take another look. So we know it runs in. On the first run, it does C is equal to C plus 1. Then it runs on to the next. R is equal to R plus C. But there's a fundamental flaw in our equation somewhere. So what I'm going to do is watch the values. If I add to C, so I've highlighted C, I'm going to right click, I'm going to go to add, watch, and then it'll appear down here. And I'm going to do the same down here, add watch. So I'll snap this back across, and then let's run it again. And let's see what value it's returning. So see there, we've got R set to 5mm, C set to 0, C is now set to 50mm, and R is set to 55. So when it runs through again, it puts a new position there. So C, right, this is where C gets incremented again by another 50mm, making it 100mm. However, R becomes 155. That's an interesting one. Look at that. So it's here. It's coming from C. C's incrementing the R. It's making the R bigger and bigger and bigger and bigger. So what we could do is, let me just think. So we got D, that should bring it out. I'm even thinking myself now. That's it. So now it will just increment itself in such a step. But what we've got is a way of creating a pattern. We've got a way of implementing a particular pattern. Now the beauty is let's say it's got 2mm. And the reason I'm doing this is I want to show you a particular thing that our pattern that this is doing now is going to allow us to do some really cool stuff with it. So if I run in, first pattern goes in. Let's get that right. Second one, third one, fourth one, fifth one. And now what we got is a set of circles which will increment themselves based on a particular value, based on a particular distance. Now that's me just using a for loop. I could, in that process, set an if statement as well. So let's say we've got an outside barrier and we want to make sure that it never compromises that. We can get an if statement to cut itself off if that gets compromised. We can get it to cut off the for loop if it becomes compromised. Many different ways that we can essentially do that. And this is known as the for loop, this one in particular. Has anybody got any burning questions about this tool? It is one of the most common tools in C programming. Anybody who's done Python, you'll know that you actually don't even have to type the word next. You don't have to add or increment. You can just drop in key symbols. It will just drop in and out, and it's phenomenal for stuff like that. Almost feels wrong writing in Python. Anybody who's done MATLAB, you'll know that for loops exist in slightly different format, but they all operate the same way. And the beauty is as well, let's say we then want to ask the user for a value that we want to ask them how many circles they want. We can literally say to the user, this is just a direct increment value. It's not a unit. So what we do here is I can change that to n. So let's run that again. And if I run that again, I can actually say 8. And it'll increment to 8 circles. Now, again, I know this is just a series of circles running along based on a 2mm distance, but think of it this way. If that value was set by a case statement from somebody inputting, you can even restrict that as well. What you end up with is a very specific way of being able to set these types of offsets. So, I'm just going to hit save on that. If you are following me with this, please do hit save. Now, there is one next tool that I want to show you. Now, this tool is very, very similar to the for loop. What I'm going to do though is I'm just going to highlight here and I'm just going to comment all that out. And what I'm going to do is repeat the process in a system called the while loop. And what while will do, while will stay active while something is true. If something is false, while will not stay active and while will stop. So what I can say is while. Now a while loop is a while. Now I need something to test against. So I can say while I know. While I is not equal to n, do this. So this allows people to put in minus numbers. It should fail on minus numbers, but it allows people to put in minus numbers, things like that. Now it's the same principle, so I'm just going to copy them in. Exactly the same principle, but there is something that you do need to be very vigilant of. And the thing to remember about VBA is if you haven't saved, it won't automatically save, and if you don't save, it is your loss. It is totally your loss. I cannot take responsibility for you hitting save. So it's just something to keep in mind that can happen. So what it does is I've said while I, and in this case I'm going to say I is equal to 0. So it's just going to start off at 0 while I'll stay consistent. So I is equal to 1, and what it will do is it will run in, and then I'm going to just type wend. Now it will run in and it will run through the loop. It will check I and it will check n. Now n is obviously going to come from the user. Now what I'm going to do is hit save. Now please do not follow me on this one, just because I am particularly going to be trying to mess stuff up. So I just need to make sure all my stuff is turned off. Keep getting comments coming in, I just have to keep checking. Right. So, if I close out, now when you enter into a loop, you must always give it a reason to be able to get itself out of the loop. Now, when I've gone in there, this test is simply while I is not the same as n. So while I is not the same as n, then do the loop. And then once I becomes equal to n, then stop. Now there's one thing I've particularly forgotten to put on there. If I hit run, let's go 5. We go, oh, gosh, what's, oh no. So, what's happening now is SolidWorks is generating, I'm guessing it must be a few thousand parts as we speak. So SolidWorks is trying to generate continuous loops now, and it's probably making an infinite amount of circles. That sketch will probably just have a gigantic amount of circles all the way along it, and what it'll do is the amount of circles that it'll get on there, it will then deposit that to the memory. As that starts to build into the memory starts to become overclocked. Once it becomes overclocked, the long status that we've all seen at the start, that we've never seen a real reason for it, the long status then starts to kick in, and any minute now, is it going to come? Let's have a look where we're at. Oh, you see how I've got the resource manager? Can I actually open that up? Be nice to see. Oh, no, because that's it. And now what will happen is it will run in, and if I hang on a minute, I know what I can do. If I just click that, you kind of go right. Oh, what if can I? Oh, basically, do not do this. If you do this and you've not hit save and you do something daft like I've just done, what it will do is it will spam your PC and you will lose everything that you've done if you've not hit save. Now, I'm going to fix this in a second, and I will fix this properly. But you see here, I not equal to n, it runs through the loop, and when it gets to beneath the change for r, I have not said I is equal to I plus 1. Basically, it's stuck in an infinite loop. I say a few years ago, but quite a few years ago, when I did my degree, if we got stuck into an infinite loop, we literally had to pull out the power plug. The plug at the back would just become, it would be the only way to get out of it. Now, the trouble is with more and bigger memories on PCs now, it takes a while to fill it up. I don't think I'm going to wait. I'm just going to try and close it. If it'll, there we go. And done. Yeah, it's going to come back and go, well, you did that. Yes, I did. So that is just one thing to keep in mind. That is why I didn't want you guys to follow me. So let's open it back up and let's fix it so it works right. So do keep that in mind. And the reason I wanted to record it is that if anybody goes back over this, I do want you to be able to see that that is one particular thing that you do need to not do. Let's come back across and let's get back in. So I've come back up to my circles, and there's my circles again. So if I come back down, so now being back on here, all I actually needed to do, and I know it seems obvious, and I know a few of you will go, well, who would do that? You'd be surprised. A lot of people do that. And it's not because of an intelligence thing, it's just because you forget. Do not forget to add. This is the only way it will increment itself out. So if I come back and bring this back across, and let's add this to a loop. So I'm going to add this to a watch. I just want to jump it in so you can see what it does. So if I run it in, wait for it. So how many circles? We'll just go 5. Nothing special. So run it in, and we're on a watch. We know I is equal to 1. It runs in, creates a circle. See there, I became equal to 2. I is equal to 3, I is equal to 4, and I is equal to 5, and now it's equal to it, and because it's equal to n, it's while it's not equal to n, so it jumps out like that. And there's our difference in sizes. Now, has anybody noticed one in particular thing about this? There are 4. When there are 4, tells us an awful lot about the way that this thing behaves. And I've used while loops all my life. I think they are the shit. I really do. They're very, very good for what they're used for. So if I run it again, so if I go 5, we'd expect 5. So it runs into there. So we go 1, draws a circle, increments I. So now it's set to 2, draws that circle. It's now set to 3, draws that circle. It's now set to 4, draws a circle. It's now set to 5, it's now equal to it, jumps out. And it's the way that these things function. So in other words, if I set this to 0, it'll run through and it stops on 5. So it doesn't necessarily mean I'm going to get 5 circles. It just means I'm going to get 5 loops. So if I run that again and go 5, because I'm starting at 0 now, into 5, jumps out, and there is our 5. So these are little tricks, tips and tricks that you do need to keep in mind of that. This is how these things will behave. There is a bit more of intelligence that you can put into a while loop. So for example, within a while loop, I could actually add multiple things to test against. So if I wanted to add further detail to this, I could literally type OR and add another test criteria within it. As within a for loop, I cannot. It's literally counting from 1 to n, and that's it. However, within here, this is a testing way. So this is where the two start to differ quite a bit and give me a bit of a freedom to be able to do stuff. Right. So let's get back to the task at hand. Now I think the while loop is going to do this better than what the for loop will. So if I come back to my test, so yeah, this was the big one why I wanted to really have a look at this, because it's a great one to work with. So we're going 1200. Now you see here we've got 20 as a starting point. If it's 20 as a starting point, let's just set it. We know that n is going to be 5. So now we're in a position where that should shift the axes from the start 20 millimeters to the right. Just measure that. 20 millimeters to the right, which is great. And now we've got an increment now moving backwards. We have d distance across. We're going to fix these anyway. Right, so Next thing that we need a corner rectangle to be on here. And the reason I'm not fussed with these is because we're going to make this proportional based on how this is going to function. So what I'm going to do is going to hit record, and I'm going to go corner rectangle, and with this I'm not too fussed. I'm going to go like there, something like that, doesn't really matter. So I'm going to go stop, put that into a dummy, and click OK. Come back across here and then go into dummy, and what we got is that is my vital piece. Well, I'll take them both, because you're just never sure what you're going to use. No, I'm just going to take them. I just need them. That's all I really need. Now, the corner rectangle is the only piece of geometry that does not get repeated. And what I would like to do is actually start this corner rectangle first. So think of it like this. I'm going to put this on here first. I'll get the user's request for width, length and width, and I'm gonna make it a bit more jazzy than this simple exercise. So what I'll do is paste in my corner rectangle. I'm going to ask the user for an input. So I'm going to go length and width. So again, I'm going to go dim L as a double. This is just because I'm going to capture what they want. So rec width, rec length, sorry. And then we'll do the same with W. And again, so we'll go rec width. Now, what we can actually do is we can set the circle, the largest circle, based on the width of the user's input. Don't get me wrong, I know it'll need a little bit more error safing. So if I go W, equal to input box, and open bracket to here, and I'll say enter width. As ever, I'm just going to put myself a little bit of a default in there just to make my life easier, because I just can't be bothered to keep typing. So what I'll do with this is I'll set that to 100 millimeters based on the notes, and then we'll close that out. And then I'm going to do the same again with L. L is equal to input box. Open brackets, open comments, so we'll go enter length in millimeters, close that, and then again just staying with the notes, so the 1200. These are just defaults. That doesn't mean that they are in for solid stone. So I've got W is equal to W over 1000, because again we are requesting in millimeters. L is equal to L over 1000. Right, so I'm going to be naughty. So I'm going to say R is equal to W over 2. Now I'm basing this one on this one. See how it was running concentric to the actual position itself. And D, now D, this is going to be quite good. I think we set D to, I'm just going to go, I don't know, we'll go W over 6, just to give it some positions. L over 6, sorry. So we'll make this L over 6. Just to give us some positions as to where this is going to sit. And center of the circle. God. We'll leave it at that for the minute. And so that now gives us some type of shaping. As ever, it's a corner rectangle, so I'm looking for the bottom left. So this is my x coordinate, where it's coming from. In my x coordinate, it's going to be at 0, and my y coordinate is going to be w over 2. Minus w over 2, I should say. W over 2. And then x coordinate for this one is going to be L. That's my length, of course. And then that is going to be w over 2. And that is obviously because, let me just spin this back, because I'm appreciating I'm just jumping the gun quite quickly there. But basically, my corner point here sits beneath the datum. And basically what I'm saying is I want that to sit there and like halfway in between, something like that. So let's just close that first. Close that. Close that. And close it. I've got lots of parts open here. So let's bring this back across, and then let's run it. This won't be right, so please don't judge me just yet. That's where my first circle sits, and it's on rad. So other thing I want to do is I'm just going to get rid of that, because that was my incrementing, and I just want to remove all increments for the minute. My D, which is distance, is obviously that over 6. So let's just make sure I can get this moving as I want it to. That first one there, that's a little bit irritating. Okay, I'm just going to be really clumsy here and see if I can move that center a little bit further. So I'll go less than 6 and go 5. No, let's just go 7 and see if that gives me anything better. Okay, let's just go 5 then. Because 5 should shift it out anyway, because I've got that center circle moving. Unless I actually do set C in this case equal to plus D. In fact, let's just move it along. I'm just going to move that manually for the minute. Okay. So what we want to do, wow, I've got myself into a corner now. So this incremented size, we actually want it to be W over the division. So it'd be W over 5. Is that going to be it? Let's have a look. Let's go plus W over 5. Put it into brackets just because I want to ensure that it's going to increment like I want it to. You see, now it's taken W completely there, completely over 2. So I am being very so if I take that over itself and then take that by 5, let's see how that works out for us. Now, that's looking a little bit more like our target. A little bit more like our target, don't get me wrong. There's still a few more bits that'd be nice to be able to complete. Totally get that. But it's looking a little bit more healthy, you must admit. Right, you'll notice here I'm still glowing blue. That could cause lots of problems for me. So what I'm going to do is I'm just going to copy me a clear selection. So when it runs in, clears all that crap out. And then what I'm going to do is I'm going to extrude. Now you see there's a few things you could do. I'm just playing around with this right now. There's a few things that you could do. We could simply extrude the profiles and then extrude a second profile within it. Because at the moment, the issue that we've got is we've now got we've actually got 6 profiles that we could extrude. So there's got to be a more efficient way of being able to do this. There's got to be a better way of being able to do this. And there is a lot of better ways of being able to do this. So what I will do first is I'm going to come back here, discard the changes, and I'm simply going to go record, front, sketch, corner rectangle, and I'm going to go extrude, and then OK, and then stop. So I'm going to override that onto my dummy. The reason I can do it is I've now even got the power to choose which way I want to go with that. I can choose how I want to extrude that, and it just gives me that little bit more of comfort of knowing which way I want to go. So you look here, we've got all these things going on here, but we've got this little beauty. Now, I don't know a lot of you, because I do know a few of you have been practicing this. So for those of you who've been practicing this, well done, because getting into this is not straightforward, and it's a bit bloody frustrating, which I'm sure a lot of you are starting to find. But if I'm going to write extrude twice on here, is that not a waste of time? Because I think that's a waste of time. What I could do is use a method that's called subroutines. So at the bottom of here, if I type sub and just type sub ex, see how that happened? See how it's now called sub and x? Basically, this is an extra bit of code I can put in here and just call it when I want it. So what I'll do is just type, well, not even type, I'll just paste that straight in. What this will do, this will run if I call it. Now, I'm going to show you what it does. This is so I don't have to keep repeating, and it's actually seen as a far more efficient way of being able to use these types of things. Now you'll notice here, the thing is we've got a sketch in here, sketches all over the place. Could be problematic. So what I'm going to do is I'm going to be extremely naughty, and I'm going to come out of this, I'm going to come down to here. In fact, really, I could put this into a subroutine as well, really. But we'll do that in just a second. And what I'm going to do now is I'm going to say, get that into a sketch. Get that into a sketch. And then I am going to, from my corner rectangle, I'm going to extrude it. So I'm going to say call X. So let's step through this. So I'm going to run it in. Run to this normal. See how it's gone to call X. Trimetric view, select selection sketch, extrude, jumps back out. Top plane. Oh, I tell you, it's delicious, it really is. So let's come back. Now if that works so simply, which let's face it boys and girls, certainly did, I am going to come back to here I'm going to say call X. Let's run this again. I'll run it to here. I just want to make sure this is running. So we've got an extrusion. Profiles on, profiles on, profiles on, profiles on. Oh, I just thought of something. Shit! Just thought of something. It's going to run in and... You bastard. Oh, that's a bummer. Right. It's not a problem. So, how do we fix that? A few different ways. So, we either choose the size of what it's going to be. So, so let's say we'll just call the extrusion. So what I'm going to do is say dim ext as a double, and I'm going to call this extrusion. Now what this is going to allow me to do is to call it when I want it. So again, this is not a value that the user is going to be able to choose yet. We'll be able to play with it afterwards. ext is equal to, and we're going to go 10, obviously for millimeters, and then from there I'll then come back in and go. I like to keep them separate, so I'll go ext is over is equal to ext divided by 1000, and then it jumps in. So we've got that ext, it's over 1000. Now what we do is jump across. Now this is where it becomes a real pain in the backside. So I come back into here, ext and ext. So let's just check it, because this might not work. And what I want to do is add a watch to that. Now I know it sounds really dull, but I'm hoping it doesn't work, because there's a few things that it looks really sexy, works really well, does its job. And this is, again, like an advanced pattern process. So you look here, ext is now set as... there. ext is set to 1. No, it's done it. It's a shame. Yeah, it's what you can find, and what you can't find that will happen is when you're running through these things, it can put you into a position where the values won't pass across, and what you've got to do is manually move them backwards and forwards, and it becomes a little bit tricky. For an easy fix on this one, all I'm going to do is say ext is equal to ext plus ext. Oh, plus ext. So basically, I'm just taking. Wow, something sold on eBay. So when I run this in again, let's just check it. So it runs in. Got the values in, circles are in position. Calls over, jumps across. ext is now set to 20, so it should now run it into position. So all I've done is just double it. What you see now is we've got. Now, one thing I really like with this is this challenge that I set you was a little bit more restricted. I just asked you to get this to loop in this particular way. And however, the one that we're using here has a lot more flexibility about it. We can set the depth of how much an extrusion works. We've got control over every single element of this. We can do pretty much anything that we want to it, and it will do exactly as it's told. Wow, I've got a lot of parts open. Now, if I'm going to set this up as being a bit more efficient, The first thing is I've got repeats here. You look and you kind of go, really? Do you want them repeats to be on there? No, I don't. I want one function to do what I want it to do, then past there, you can do whatever. So I'm going to set another subroutine up. I'm going to say sub, and I'll just call this SK for sketch. See there, it jumps straight back in. It's give me the lower points and upper points, so it's start sub and there is an end sub. These little tools are amazing for doing this type of thing. So I'm just going to take this, I'm going to copy, and again I'm just dropping straight into this subroutine just so I can just use this once. That's all I need it for. And then with this I'll call, get rid of that, call SK. And then again up here, SK. And now when you actually look at the amount of code that we've done, it becomes less and less. We've actually been able to remove these lines from having to be used multiple amounts of times. We've got control of them extrusions. We have control of the plane selection. We're actually cooking with gas, in lack of better words. Now the other thing that we didn't have control of was EXT. So just for shits and giggles, let's set some control within it. So I mean, it really is that simple. Input box So now, again, I know it's the most simplest of geometries, but we've now got a pattern that will allow us to increment in a key particular type of way. We're in a lot of control with this. So close that off, close that off. Just shut a few of them down. I'll tell you what, I'll come back to it. And if I run that again, yes, yes, and then we'll go 15. And this obviously should have a full extrusion 30 millimeters, but a 15 offset between the two. Another alternate way of being able to do that and to control that rather than doing EXT plus EXT, because the issue is with me putting in EXT plus EXT, what it actually does is it removes that element of the user being able to choose that point of control, but it is at least usable. So, any questions on that? Phenomenal, phenomenal. Has anybody struggled to get this working? So I'm just looking through my questions here. Okay. Then if no one has struggled to get this working, then I am ultimately going to set you another challenge right now to see who can get this to work. Whew. So, with the amount of stuff that we've done so far, and the amount of different things that we've been doing so far, I just want to make sure I've got the other... I do have a set of notes that I'd put up today, everybody, in case you didn't know. Let me just scroll this across. Subroutines. I just want to see if there's any nice challenges in there. There's one particular challenge that I'm dying for you guys to take a look at, but I don't know if there's anything very good in particular in here, so let me just have a look. Where is it? So ifs and cases, we've just been working. We've worked quite a bit on them. So objects and methods. Subroutines. Yes, we've just been doing subroutines. Right, excellent. So these are just other examples of subroutines where you can pass values out. Now these are really basic and simple ones. I just thought I'd use a subroutine for a bit more with aggression today, rather than just doing this, because this just simply pass values backwards and forwards. I wanted something a bit more tangible for you all to see. So hence why that's a bit more of a bigger example. This I don't really go through. I put it in there because everybody asks about changing colours. You can change colours, but that I'll let you have a play around with. Right, so then the next big question, well, the next big thing I want you to have a go at, whoops, apologies, is this. This is the I-beam section. I know we've got another 28 minutes left, so I'm going to give you, for the next 10 minutes, to get the I-beam geometry in position and moving. So, and then I'm going to take you through a quick process of setting these things up and how quickly they can be done. Don't forget, on here we have thickness to FT, we have WT, we have HT, we have WI, but rads are controlling these edges, these edges, these edges, and these edges. All of these are all the same rad, so that's one thing to keep in mind. But as I said, you have 10 minutes starting now. This set of notes, this example, I will be uploading to Blackboard. I will upload that to Blackboard today for at least for you all to take a good look through and to have a big ponder around. If you do anything, I would honestly get used to being able to call subroutines and also being able to use these little while loops. If you're after first class in your assignment, I'm expecting to see these done well. I'm expecting to see these well laid out. I'm expecting to see subroutines. I'm expecting to see quite a bit. So these are important things for you to take a look at. So please do, if you well, you do need to keep practicing, I should say. So I am going to save that. When it comes to the I-beam, many ways with it. I mean, we've done it really. I mean, we did the e-cigarette mouthpiece. You think about that cross section that we did. Think about how that's been put together. It's so straightforward. It's crazy. It really is. So what I'll do with it is come back over here now. And I know a lot of people have said to me before, well, why don't you just record a new part every time? I don't really need to at this point. I know how to get them. Not interested really. I do know how to get them. I do need to close some of these parts down, or else my PC is going to start hating me with a vengeance. What I'll do though, just for completion, is I'll record and go front and go part. And the biggest indicator here tells us an awful lot is that origin. We know it's an I-beam. And I know I've had a lot of students in the past go, oh, you can't do that because that's just not right. Yes, I can, because I'm doing it. So I'll go front, sketch, and sketch. So I'm going to go here, to here, to here, to here, to here, to here, to here, and to here, to here, to here, to here, to here, to here. Shoot, I should not have scrolled, but I did. So we'll call this I-beam. And I'm going to go onto my I-beam. And the troubling thing is now is I should have a scroll. Yeah, this. You see where I scrolled then? That's what this did. So annoying. So I'm going to delete all that out because that's totally pointless. And as ever, you guys should now, or at least be confident to know that now, a lot of this isn't actually needed. So that isn't needed, and that isn't needed. So that now puts it into a state here. And what we've got is we've got these key dimensions, and in your assignment you're probably going to have to do the same thing. I want you to find standards. I want you to find particular standards. So WI as a double, then WT as a double, HT as a double, and so FT, yeah it is, dim FT as a double, and then well I'm gonna put rad in, so I'm gonna go dim rad as a double. And what I'm trying to challenge myself with now is, can I set this up before we run out of time? I'm skeptic, very skeptic. So we know there that went along X, so that tells me that that is WI. Oh, in fact we'll come back because I know what that. We know the next starting point from there is going to be my position of where my last line left, WI. We know that then that increment here is going to be starting from the same position, WI, but moving up in Y, which tells me it's FT. So I'm going to just remove that back in, bring that back down. And again, just because I'm rushing and all in all cheating, put that into there. That takes to there, and we now know that the next position from that, because if it's FT, it's going to be minus. So it's going to be minus WT. It's going to be, yeah, it's going to be WI minus WI over 2 minus, oh no, it'll be WI minus WT all over 2, and that'll give us that distance across to there. Oh, I'm running out of time. I'm not going to force this down your throats, but please do have a go at this. The only reason I'm saying that is the next set of incredibly difficult and tricky, mind-boggling, annoying, frustrating, and just all out getting you annoyed notes is on I-beams. So please do have a go at this and do familiarise yourself with this. What we've done today, so in recap, what we've done so far is we started off with basic geometry. Then we moved along. We started to move out to plotting out how geometry will start to look. We revolved. Then we started to move circles around, if you remember. We'd moved because we were doing the O-ring for position. Then what we did is we started to put if statements in, putting restrictions there. And then if there was a predefined amount of something, so if the user chose 5mm, we put out 2mm as an example. Then what we did from there is we looked at that all-important thing that everybody's going to get annoyed with: patterns, routines, flowing in this way. So that was one of the main reasons I always put that there, because I know it's not obvious, but this is a pattern. And what we did with the way that we've just solved that is we've made it variant. Really, what we could do with doing is we could do with putting a restriction on. If the user puts in a certain level less, that this division becomes even less. So it can only loop itself to fit proportionally. There's lots of things we could do with that. And we did that through two particular ways. We used a for loop to increment itself, like do this once, do it twice. Now, the issue is with the for loop is it will only loop itself a particular number of times. It's great to recycle and recycle, if you know what I mean. It'll go through that process 1, 2, 3, 4 up to that particular number. So if you're just wanting to do a sequence, then this is your daddy, really. It's the one to go for. If you're wanting a little bit more sophistication within it, now I'm going to be introducing some more while loops, some more head doing while loops as we go through. But if you want more sophistication into your testing, if you want to be able to test for multiple things, or if you want to nest an if statement inside of a while loop, this is how you do it. You use a while loop, and a while will allow you to jump in and out, but don't forget, a while does come at its limitations. So when I first put in there, I had I set to 1. When it ran through, I wanted 5 loops. It gave me 5 loops, but it only gave me 5 loop processes. It didn't increment to the drawing. So a way for me to solve that was to set I backwards by 1. So it actually ran 6 loops and gave me 5 drawings. You do need to have to get used to the way these things loop. Also, what we did is I showed you what happened if you forgot to add an exit point. If you get stuck in an infinite loop, it will just have a meltdown. I don't know. In fact, let me just hit pause. Let me stop. Sorry, and I'll just stop recording. For anybody who